One of the most important topics in the physical science section that's related to circuitry is resistors and resistance. Now, a resistor is any particular device that offers a resistance to the flow of current or electrons. As those electrons flow through a resistor, the resistor causes the electrons to dissipate their energy. Now, this is something that we're actually quite familiar with in our everyday lives. For example, a toaster oven is just a specialized resistor. If you were to look inside of a toaster oven while it was on, you would see the heating elements glowing hot. And this is exactly what resistors do. They allow for the movement of electrons, but they offer resistance against the flow of those electrons and cause the electrons to dissipate their potential energy. The energy that is released can be used to do useful work, like toast your toast, or it can be used to run a television or an MP3 player or any particular electronic device. Now, the mathematics of resistors is very important for you to understand on test day. So let's look at the equation that governs resistance. This equation, which you have here, is R is equal to rho times L divided by A, and we'll define each of these terms. Rho stands for resistivity, and we'll talk about that in a moment. L is the length of the resistor, and A is the cross-sectional area. Now, resistivity is an intrinsic quality of a material that is a measurement of its intrinsic resistance to the flow of electrons. Those materials that offer very high resistivity are called insulators. They do not allow for the flow of electrons. Those materials that have very low intrinsic resistivity are called conductors, and those conductors that have moderate amounts of resistivity are known as resistors. We also see that there is a direct proportional relationship between resistance and the length of the resistor. As the length of the resistor increases, the resistance increases as well. And finally, we see an inverse proportionality between resistance and cross-sectional area. As the cross-sectional area of the resistor increases, the overall resistance decreases. Now, this is an important relationship, and it's due to the fact that as we increase the cross-sectional area of a resistor, the number of pathways that the electrons can take increases as well. These pathways are known as conduction pathways. So increasing the cross-sectional area results in an increase in the number of conduction pathways, and this results in a decrease in the overall resistance. Now, resistors can be hooked up into circuits in different ways. One way is to hook them up linearly or all in a row, and this gives us resistors in series. The mathematics of resistors in series is to add up all of the individual resistors or resistances to generate the resultant resistance. Now, based on the equation that we've just looked at, R equals rho times L divided by A, you can see that the summation of the individual resistors is in effect producing a resistor whose overall length is increased. Another arrangement of resistors is in parallel. Now, parallel resistors offer alternative pathways for the current to travel. The current can travel through one resistor or another. Now, since we have alternative pathways, the effect of resistors in parallel is to increase the overall cross-sectional area of the resultant resistor. As we increase the cross-sectional area, as we've seen, the overall resistance decreases. So the mathematics of resistors in parallel is different than the mathematics of resistors in series. For resistors in parallel, we take the sum of the reciprocals of the individual resistors to equal the reciprocal of the resultant resistance. So on the MCAT, when you're dealing with a problem of circuits and resistors, think about your everyday experiences with resistors like toaster ovens, televisions, and MP3 players. And as you think about those everyday experiences, remember that a resistor is just a device that allows for the electrical potential energy found in the electrons to be released and to be used in some useful way.